Good morning, all. Let us see the exercise based on the examples exact, non-exact, which we have seen in previous lecture. So, in based on these points, exact, non-exact points or exact, non-exact formulae, let us see the further examples. So, solve 1 plus xy into y dx plus 1 minus xy into x dy equal to 0. So, here check for the, as dx dy are in the numerator, so check for the exact condition. My equal to nx condition. So here roughly we have to check this because we don't know that this example is of exact or not. So whichever the condition fails, that calculation uh, uh, that calculation we can't write in the fair or in the answer sheet. So we have to check all the conditions in rough. So whichever the condition is correct for this example, that condition or that formula only we have to write here. Otherwise rough calculation or the formulae which fails for this example, there are no any marks for these calculations. So here roughly you can check for exact condition. So m dx plus n dy, so m is your 1 plus xy into y. So simplify first this by multiplying y, and n dy, that is n is 1 minus xy, x, that is x minus x square y. So my is my with respect to y, x is constant, so y derivative with respect to y is 1 plus with respect to y, x is constant, right as it is. Y square derivative with respect to y is 2y, and x is with respect to x, x derivative is 1 minus with respect to x minus y is constant and x square derivative is 2x. So both are not same, hence it is not exact. It is non-exact or not exact. Hence check for these rules 1, 2, 3 and 4. So first check these two rules, homogeneous and ydx x dy form. So homogeneous is there or not, let us check. So here by multiplying, this is your m, this is your n. So here the power is 1, here the power is 2 plus 1, that is 3. So in m the condition fails, hence no need to check for n. So it is not homogeneous. Now check y dx plus x dy form. So this is your y dx plus x dy form, because the form is y dx plus x dy and the remaining terms should be in multiplicative form, the multiplication of x into y. All the terms contains x into y terms, not x square plus y square or x plus y etc. It contains only xy, then x square y square, that is product form of x into y, and then y dx separately, x into y terms, and then x dy separately. So this example is of this type. So let us check for that. Y dx plus x dy, and then in remaining bracket the term contains x into y term. The term contains x into y term, that is product of xy term, or the bracket contains xy terms, x into y term. Hence this is your f of xy y dx plus f of xy x dy equal to 0. So what is the formula for finding if? If equal to 1 upon m into x minus n into y. So if equal to 1 upon m into x minus n into y. So m is your this value m dx. Don't take only this 1 plus xy. This is not your m. M is your this after multiplying y. So m means dx coefficient. So dx coefficient is y into 1 plus xy. Y into 1 plus xy. And n means dy coefficient, x into 1 minus xy. X into 1 minus xy. So this is your m, this is your n. So 1 upon m into x minus n into y. So multiply x to this m, multiply y to this n. So by simplifying, so x multiplying we get xy plus x square y square minus multiplying to n by y yx, that is xy minus x square y square, but minus n into y is there, so minus n y, n value is x minus x square. So we have to multiply minus y to this both, so minus xy minus minus plus x square y square. Simplifying, we get 1 upon 2x square y square. So this is your if directly for this third form. Then multiply if to given equation 1, that is 1 upon 2x square y square, to this equation 1. So y upon 2x square y square, this bracket dx, plus x into, or this 1 minus xy into x upon 2x square y square into dy equal to 0. Simplifying, that is multiply this term to this bracket, this term to this bracket. So y upon 2x square y square plus y into xy upon 2x square y square. So y into y square y square get cancelled, x upon x square 1x get cancelled, so 1 upon 2x dx, plus multiply this x upon 2x square y square to this bracket, so we get x upon 2x square y square minus x square y, so minus x square upon x square cancelled, y upon y square 1y cancelled, so minus 1 upon 2y dy equal to 0. So after multiplying if, we get this differential equation, and which is your exact. Write this sentence, and once we get exact differential equation, so formula is same. So integration of m dx plus terms in n free from x dy equal to c. Integration of m, so which is your m? This is not your mn, these mn are your from the non-exact differential equation. We have to select mn from exact differential equation. So this is your mn, this is your m, this is your n. So integration of m dx, y get cancelled, so 1 upon 2x square y plus 1 by 2x dx, plus terms in n free from x dy. We have to pick, or we have to select the term in which x is absent. So this is only term in which x is absent. Here x is present, so x is absent. Take this minus 1 upon 2y dy equal to 0. So simplify. Take the integration 1 upon, with respect to x, 1 upon 2y is constant, right as it is. 1 upon x square integration is, x square means x raised to minus 2, x raised to minus 2 by the x raised to n formula, x raised to n plus 1 upon n plus 1, that is your standard integration formula. So x raised to minus 2 integration is x raised to minus 2 plus 1 upon minus 2 plus 1, x raised to minus 1 upon minus 1, that is minus 1 upon 2y, and x raised to minus 1 means 1 upon x, plus 1 upon 2 as it is, 1 by x integration is log x, minus 1 by 2 as it is, 1 by y integration with respect to y, as 1 by x integration with respect to x is log x, 12 standard formula. So 1 by y integration with respect to y, same variables, so integration is same, log y equal to c. Simplifying, we get the answer. So 1 by 2 take common, so log x minus log y, you can write as it is, or you can simplify this by using log rules. Log x minus log y, log a minus log b is log a by b, so log x by y. Next is dx dy in numerator, so check for the exact non-exact condition. So here this is compare this given equation with you can write this directly, compare this with given equation with m dx plus n dy equal to 0. Because it is similar, it looks like similar to m dx plus n dy equal to 0. So m is your this bracket dx coefficient, and dy coefficient is your n, so n is your minus x square y. So find check the condition for exact. So my with respect to y, this is your constant, partial derivative is there, this is your another notation for partial derivative. You can write da by m by da by y, or m and suffix y, that is my, partial derivative notation, another partial derivative notation. So my equal to, with respect to y, e raised to 1 by x cube minus e raised to 1 by x cube is constant, so constant derivative is 0, so only take the derivative of this. So with respect to y, x is constant, write as it is. Y square derivative with respect to y is 2y. Then with respect to nx, find nx. So with respect to x, y is constant, write as it is. Minus x square derivative is minus 2x. So both are not same. That is equation 1 is non-exact. So check for the 4 rules. So check for the homogeneous condition. This is not homogeneous because this has the power 3. This has the power 3, but it has no power because in the power there is another term 1 by x cube. So we can't get the power of this term e raised to 1 by x cube. We can find the power of this term 2 plus 1 3 because in the power there is a number 2 and 1. 2 plus 1 3. 3 power term is there. 3 power 1 plus 2. But we can't find the power, hence this is not a homogeneous. Then y dx plus x dy form. So here y dx plus x dy. So here x square means x dy is there. X square means x into x. So x dy is there, but we can't take y common from these two terms because it here y is absent. So y dx is not there. Form is this y dx plus x dy. So first check for this y dx plus x dy and then go for the xy product form term, xy multiplicative terms. Go for the second, but for the first check for the y dx plus x dy. Is it y dx and x dy? Both the terms are there or not, and then check for the multiplicative equations with y dx and x dy. So here y dx is not there, hence it is not of that form. Now check for the first two rules, these two rules. So find my minus nx. This is all you have to check in rough. So my minus nx upon n or nx minus my upon m. So here first roughly check my minus nx upon n. So my means partial derivative of m with respect to y. So already we have found that, or we have calculated. My is 2xy, put these values. 2xy minus plus 2xy, that is 4xy upon n value is minus x square y. Simplifying we get minus 4 by x, and this should be f of x only, and we got that equation in x. So this is your my minus nx upon n. That is not your if. If formula is different. So if equal to e raised to integration fx dx minus 4 by x dx. So e raised to minus 4, 1 by x integration is log x. Take minus 4 in power. So e log x raised to minus 4. E log get cancelled. Directly you can, by imagining, you can directly write the answer. So e log x raised to minus 4. So e log get cancelled. Answer is x raised to minus 4. X raised to minus 4 means 1 upon x raised to 4. Then multiply this if to this given equation, that is 1 upon x raised to 4. So this bracket upon x raised to 4, this term upon x raised to 4. Simplifying we get x square get cancelled and this term. So after multiplying if, this example is your exact differential equation. And once we get the exact differential equation, so for this equation use this formula, exact formula, integration of m dx and terms in n free from x dy equal to c. So here in this exact differential equation we have to find m value. This is your m value dx coefficient, this is your n value with minus sign, dy coefficient. So put in this formula, integration of m dx, this is your m, separate out these terms, xy square upon x raised to 4 minus e raised to term upon x raised to 4 dx plus terms in n free from x, so minus y upon x square. So in n, here n value is minus y upon x square. So it contains x. So here x is, the x absent term is not there. Hence we have to take 0 dy equal to c. So find only this integration. So here y square is constant. Write as it is x upon x cube. So 1 upon x cube minus as it is dx equal to integration of 0 is 0 is equal to c. So y square as it is 1 upon x cube integration is take in numerator. Use x raised to n formula, integration formula. So x raised to minus 3 plus 1 upon minus 3 plus 1, that is x raised to minus 2 upon minus 2 minus y square upon 2. X raised to minus 2 means 1 upon x square minus this integration is remaining. Now this integration is different. We have to, there is no any standard formula. So thinking is same. That is this. There is no any standard formula. There are two terms. One is in numerator, another is denominator, and these three formulae are only for the single terms. There are two terms, so it fails. Then is there any shortcut formula? No. F dash upon f x raised to 4 derivative is 4x cube. So there is no any case like that. F dash upon root f or e raised to f into f dash. E raised to f is there, but f dash is not there. Or you can, here you can use this formula also, because I am using here substitution method. Or you can check this for integration of e raised to f into f dash. Here e raised to f, this is your f, into f dash dx. So if you consider this f, so f dash should be also here. We want f dash also here. Then only you can use this formula, e raised to f into f dash. So find first this f value, f dash value of this f. 1 upon x cube derivative is, so x raised to minus 3 derivative is minus 3 x raised to minus 3 minus 1. That is minus 3 upon x raised to 4. Yes, you can use this formula directly, or you can use the substitution method. So I will show you how we can use this formula. So here minus e raised to f, this is your f. F dash is minus 3 upon x raised to 4. Directly take this f dash, and extra we are taking minus 3. So cancel this minus 3. So we have to adjust here minus 3, and constant you can adjust. 1 upon x raised to 4 is there, because f dash contains 1 upon x raised to 4, and 1 upon x raised to 4 is there. Only minus 3 is absent, or so that you can adjust minus 3 by multiplying and dividing. So take minus 3 outside. So this is 3 e raised to f into f dash. So the answer is, or the formula is, e raised to f into f dash is equal to integration answer is directly e raised to f. So here e raised to 1 upon x cube is your integration answer. E raised to 1 upon x cube. Directly write this. Or you can use the substitution. Use this formula. Or you can use the substitution as put substitution method. If there is a no any shortcut formula, then for UV rule we can't use here, because here exponential term means it comes last. So this is your v, and u is your 1 upon x raised to 4. That is x raised to minus 4. And x raised to minus 4, for u applying UV rule, there is a one condition, that derivative of u must be 0 at any step, any step, or further derivatives at any step, the derivative should be 0 for u. But here for x raised to minus 4, we can't get the derivative of u as 0. You can check that for x raised to minus 4, we can't get derivative equal to 0. Hence, you can use substitution method. So substitution is put 1 upon x cube is equal to t. Why we are using this t equal to 1 upon x cube? Because after taking the derivative, whatever we get, that variable term also should be present in the substitution, so that your substitution will be correct. So put 1 upon x cube equal to t. So take the derivative on both sides. So x raised 1 upon x cube means x raised to minus 3. X raised to minus 3 derivative is minus 3 x raised to minus 3 minus 1, that is minus 4 dx. This is your substitution method in the integration. dx equal to t integration is dt. So minus 3 upon x raised to 4, x raised to minus 4 in denominator is x raised to 4 dx equal to t. So 1 upon x raised to 4 dx, we have this variable term we have in the integration, hence our substitution is correct. So put the whole integration in the t variable. So integration of e raised to t 1 upon x raised to 4 dx, 1 upon x raised to 4 dx is, take this minus 3 on right side, so dt upon minus 3, dt upon minus 3 equal to c. So take minus minus plus 1 by 3, e raised to t integration with respect to t is e raised to t, because e raised to x integration with respect to x is e raised to x, e raised to t integration with respect to t, same variable is there. So 12th standard integration formula, e raised to t, e raised to t. This is your answer. Put t again, 1 upon x cube. So e raised to 1 by x cube equal to c. That is your answer. So you can use substitution method or directly this formula, e raised to f into f dash equal to e raised to f. So use this formula because it is shortcut formula. Next example you can take as a tutorial. Then here dx dy are in the numerator, so m dx plus n dy, compare with m dx plus n dy. So this is your m, this is your n. First check for the exact condition, my is this, nx is this. So nx minus my, again take for the tutorial. I will show you if the integration is difficult for solving, then I will explain that integration. Rest of the all the calculations you can solve as a or that example or these steps, calculative steps you can solve in the tutorials, tutorial examples also. So take this tutorial my nx, then this example is of nx minus my upon m, we get the fy only. So integrating factor is e raised to fy dy. So multiplying if to this equation 1, so we get the exact differential equation 1. So this is your new m and new n. So here integration of log y and integration of this. So here I will explain you what is the integration. So with respect to x, log y is constant. This is your constant actually. So constant integration with respect to x. So k integration with respect to x is kx. So log y integration with respect to x is log y into x plus. So this integration is. So here minus log y upon y. So here there are two terms, logarithmic and 1 upon y, that is algebraic. So no standard formula, 9 formula, bracket formula. So shortcut formula is there or not? F dash upon f, that is denominator derivative we want in numerator. So y derivative is 1. No, this formula fills. Root is there, again this formula fills. E raised to term is there, this formula fills. Then uv rule. uv rule we can't apply because logarithmic comes first by the layered sequence. So log y is your u and algebraic comes after this log. So 1 by y, u is your term log y and v is your 1 by y. So log y derivative we can't get 0 value at the further steps. So derivative of u is not 0 in the higher derivatives or the first derivative, second derivative, third derivative. The derivative of u should not be 0 at any step, hence we can't apply uv rule. Then substitution method. So use substitution method. So what is the substitution? Put log y equal to t, so that log y derivative is with respect to y. Log y derivative is 1 by y dy. Log y derivative is 1 by y dy. T derivative is dt. So 1 by y dy is also present in the integration. Hence our substitution is correct. So convert this whole integration in t. So put log y equal to t. So minus log y is t, 1 upon y dy, 1 upon y dy is dt. So minus t dt. So t integration with respect to t is t square by 2. Because x integration with respect to x is x square by 2 by using x raised to n formula. Integration formula. Put t value again log y, so log y bracket square upon t. This is your answer. Then next is, again take the tutorial. This is your y dx plus x dy. So this is your this form. I will explain you how this example is of this type, and then you can take you can take this example for tutorial. So y dx is there, x dy is there. In the remaining bracket, all the terms should be in multiplicative form. So x into y, multiplicative form. X square y square means x into y, x into y. That is again multiplicative form. X into y, x square y square. That is, this example is of the type this form, and you can solve this further. Next, y dx minus x dy plus log x dx equal to 0. So there are two dx. So we have to first combine these two terms, dx terms. So take dx common. So y plus log x dx minus x dy equal to 0. So dx dy are in numerator. So check for the exact condition. This is your m, this is your n, my is 1. With respect to y derivative is 1. Log x is constant, derivative is 0. Nx, n is minus x. So derivative with respect to x is minus 1. So non-exact. So this is the example of my minus nx upon n type. So take this as tutorial again. Now I can explain the integration only. So here this example is of the type my minus nx upon n. So put my value, nx value upon n value. N is your minus x. So we get f of x only. It should be, this is your rule. Then if is e raised to integration fx dx minus 2 1 by x integration is log x. That is, simplifying we get 1 by x square. Multiply this if to the given example. That is, this bracket upon x square, this minus x upon x square. So minus x upon x, that is minus 1 upon x dy. After simplification we get y plus log x upon x square. So after multiplying if, this is your exact differential equation, and hence this is your new m and new n. So for exact differential equation, the solution is integration of m dx plus terms in n free from x dy equal to c. So integration of m, this is your m value, dx plus n dy. So in n, we have to pick the term which contain in which x is absent. So here there is only one term, minus 1 by x. That is, here x is present, so we can't get the terms in n free from x. That is, pick the term in which x is absent. So here x is present, so we have to take 0 dy equal to c. So now find this integration only. So separate out first y upon x square plus log x upon x square. So y as it is 1 upon x square integration is this. So 1 x raised to minus 2 in numerator. So x raised to minus 2 integration by x raised to n formula. X raised to integration is x raised to n plus 1 upon n plus 1. So x raised to minus 2 plus 1 upon minus 2 plus 1. Simplifying we get minus y by x. Then log x upon x square. So now this is the integration. New integration is there. Actually, this type of examples many times we solved in 12th standard. But again, I can explain you. So here, what is this sequence? So by sequence, you can find the solution for evaluating the integration. So here log x upon x square. So here log x is your u, because by Lie sequence, logarithmic comes first. So this is your u. And 1 upon x square is algebraic, comes after L. So 1 upon x square is your v. So u means log x. So derivative of u. So there are two terms. So this first three are for single terms integration. So it first three fails. Then there is no any shortcut formula. Then uv rule is not applicable because derivative of u doesn't come 0 at any step. Then substitution, so substitution is not there. You can use put log x equal to t, but we can't get the after derivative, we can't get the that derivative term also should be there. So if you put log x is equal to t, 1 by x dx is equal to dt, but there is a 1 by x square. So if you put split this log x into 1 by x, 1 by x, so for log x it is t, 1 by x dx is it is dt. So what is the value of 1 by x, because whole integration we have to convert into t. So for 1 by x there is no any t term, hence log x equal to t, substitution is wrong. Put 1 by x square equal to t, but after taking derivative, whatever we get here, this term is not there, because for 1 by x square we put t, so 1 by x square converted to t, but for log x how we can use, or how we can convert log x into t variable? So again it is wrong. So there are only two terms, so uv rule, substitution method we can't use. Now we have to use the Liet rule. So Liet rule is u and v. So Liet rule is first function into integration of second minus integration of second, that is this term and this term is same. So write this answer directly here. First function into integration of second minus integration of second with respect to whatever given in the integration, with this integration of second into derivative of first. I am writing in the short. So u integration of v minus integration of v into derivative of first. So log x derivative is 1 by x dx. So log x as it is, 1 by x square integration is x raised to minus 2 integration is x raised to n formula. X raised to minus 2 plus 1 upon minus 2 plus 1. X raised to n plus 1 upon n plus 1. That is your form. So x raised to minus 1 upon minus 1. Integration is evaluated. Minus integration of this term is this term. So its answer is this. So directly write this answer. So x raised to minus 1 upon minus 1. So simplify this second integration. Minus log x upon x. Minus minus plus. This x raised to minus 1 means 1 upon x. So 1 upon x, 1 upon x, 1 upon x square. So 1 upon x square integration is, that is x raised to minus 2 integration. So we have evaluated here. So integration is x raised to minus 1 upon minus 1. That is minus 1 upon x. So this term and this term. So here this is your Liet rule. So minus log x upon x minus 1 upon x. Minus 1 upon x. So throughout multiply by minus sign or write this answer as it is, or you can simplify this also. So in this example Liet rule comes first time, but actually this Liet sequence or Liet rule examples we have studied in 12th standard or in M1 also, and I have also explained right now. Next is take this tutorial. So as there is a dy by dx, so you can check for the LD equation, Bernoulli equation and reducible form. But for LD equation, y variable term is we want separately, or for dx by dy x term separately. So there is no any term like that. So these are this is not a LD, Bernoulli and reducible form. Then go for the exact non-exact condition. So for that dx dy should be in numerator. So take this xy square here and dx here, and then all the terms in the on the left side. So we get m dx plus n dy equal to 0. So this is your value of m, this is your value of n. So this is your homogeneous equation. If you see, degree 3, degree 3, 1 plus 2, 3. So each term having same power, same degree. Hence this is your homogeneous. But before homogeneous, first check it is exact or not. So you can see directly that this is homogeneous, but homogeneous condition is when we get the non-exact condition. So first check the exact condition. So this is your m, find my, then nx. So this is non-exact example. So by homogeneous condition, solve the example. Then next is this, take as a tutorial. Again this is of the form my minus nx upon n. So dx dy are in numerator. So this is your m, this is your n. So this is non-exact. So check for the for rule. This is not a homogeneous, this is not a y dx plus x dy form. So check for my minus nx upon n or nx minus my upon m condition. So this is your final answer. So these are the some examples, exercise examples for exact, non-exact rules. So let us see the next point in the next lecture. Thank you.